They say motorcycle oil is special, designed for heat, high RPM, and even the clutch itself. But is that true? We'll break down what's really inside, run the numbers, and test whether motorcycle oil is worth the money, or if your regular car oil can do the same job. 1 oil, 3 jobs. When you pour oil into a motorcycle engine, it doesn't just lubricate pistons and bearings. In most bikes, that same oil also runs through the transmission gears and the wet clutch. That means one liquid is doing the work of 3 separate fluids: engine oil, gear oil, and clutch fluid. Each system needs completely different characteristics. The engine wants low friction for efficiency, the gearbox demands extreme shear strength between gear teeth, and the clutch actually needs the right amount of friction to engage smoothly without slipping. If the oil is too slippery, your clutch can start to slip under load, especially in high-torque V-twins or sport bikes. But if the oil's too sticky or too thin after shear, you'll get rough shifting, higher wear, and a quick drop in performance. That's why motorcycles are so hard on oil. Every gear shift shreds the viscosity modifiers a little more. Every time the clutch engages, it adds heat and microscopic wear debris. Eventually, the oil that started as a 10W40 might behave more like a 10W30 or worse. In contrast, car engines use a separate transmission system, so the oil never faces that kind of mechanical stress. That's part of the reason car oils can afford to focus on friction reduction and fuel economy, things that don't translate well to shared sump motorcycles. So before we even hit the test bench, we already know one thing: motorcycle oil has a much tougher job to do. Inside the lab, how motorcycle oils are actually tested. To find out if motorcycle oil really earns its higher price, you have to look beyond marketing labels and straight into the lab tests that define performance. Inside a testing facility, every oil sample goes through a series of mechanical and chemical trials. These aren't random stress tests. They're based on standardized procedures like ASTM D5800 for volatility, D6278 for shear stability, and the JASO MA/MAA. 2 clutch friction tests designed specifically for motorcycles. The first check is viscosity stability. Engineers use high-speed shear machines to simulate what happens when gears mash together thousands of times per minute. If the oil thins too quickly, it means the viscosity improvers have broken down, something car oils often struggle with in shared sump bikes. Next comes wet clutch friction testing. In this setup, a clutch pack is spun under pressure and heat, while sensors measure how consistently the plates grab. Too much slip, and the oil fails JASO certification. Too much stick, and you get harsh engagement that riders can actually feel. Then there's thermal oxidation and deposit testing, where the oil is run hot for hundreds of hours, sometimes beyond the recommended drain interval, to see how much varnish and sludge form on metal parts. Each of these tests tells a story. Viscosity drop shows shear stress, clutch slip shows additive imbalance, deposits show heat stability. Put together, they reveal what car oils can't handle, and what motorcycle oils are specifically built to survive. The friction modifier problem. One of the biggest reasons you can't just pour car oil into your motorcycle is something called friction modifiers. In modern cars, these additives are used to improve fuel economy by reducing internal friction. Less drag inside the engine means better mileage, and that's great for cars. But in motorcycles with wet clutches, those same friction modifiers can be a disaster. A wet clutch relies on the oil's grip between clutch plates to transfer power. If the oil is too slippery, the plates can't hold together under load. The clutch starts to slip, heat builds up, and performance drops fast. That's why motorcycle oils are labeled with JASO MA or MA2 certifications. These tests measure exactly how much friction the oil allows. MA oils have a moderate level of friction, smoother engagement, often used in off-road or racing bikes. MA2 oils offer more aggressive grip, ideal for heavy street bikes or big V-twins that put down a lot of torque. On the other hand, most modern car oils carry an API energy conserving or resource conserving label. That's your warning sign. It means the oil contains friction modifiers, and that it's not meant for a shared sump or wet clutch engine. So while it might look like a good deal on the shelf, using the wrong oil can cause your clutch to slip, your shifts to feel inconsistent, and in the worst case, leave you stranded halfway through a ride. The heat problem. Air-cooled reality. Heat is the silent killer of every motorcycle engine. Unlike most cars, which rely on large radiators and liquid coolant systems, many motorcycles, especially cruisers and older models, are air-cooled. That means the engine depends on airflow to stay within safe operating temperatures. But when you're stuck in traffic or crawling through a slow parade, that airflow nearly disappears. Temperatures under the seat can soar past 300 to 400 degrees Fahrenheit around the cylinders. At that point, it's not just the metal getting hot. The oil itself begins to break down. When oil overheats, its molecules start oxidizing, forming varnish and carbon deposits. The viscosity can thicken, additives begin to burn off, and the oil's protective film weakens. You might notice more noise from the top end, or the clutch feeling grabby. Motorcycle oils are formulated to withstand this abuse. They include stronger antioxidant and detergent packages to fight thermal breakdown and sludge. Some are even tested beyond standard drain intervals to simulate worst-case scenarios, like long idling during a rally in 95-degree weather. In contrast, car oils are rarely exposed to that kind of sustained heat stress. They're protected by larger oil capacities, more stable operating temperatures, and better cooling systems. That's why high-quality motorcycle oil isn't just about smoother shifts. It's about survival. When air cooling leaves your engine baking, your oil becomes the only line of defense between metal parts, moving thousands of times per second. Shear stability. When oil gets torn apart. Inside a motorcycle engine, oil isn't just floating peacefully around metal parts. It's being squeezed, smashed, and sheared thousands of times every second. The gearbox alone is brutal. Gear teeth bite together with enormous force, grinding the oil molecules in between. Add a wet clutch to the mix, and the stress level skyrockets. To survive that, oils rely on viscosity index improvers, or VIIs, long-chain molecules that help the oil stay thick at high temperatures. But under mechanical stress, those molecules can literally be cut apart. When that happens, the oil permanently loses viscosity. A 10W40 might quickly behave like a 10W30 after just a few thousand miles in a shared sump bike. That's called shear down, and it's one of the main reasons motorcycle oils are formulated with more shear-stable 7s and tougher base stocks. In contrast, car oils never see that kind of abuse. Their transmissions use separate fluids, so the oil's life is easier. That allows automakers to focus on fuel economy and lower friction, not on surviving gearbox-level pressures. When an oil shears too thin, the protective film weakens. Bearings lose hydrodynamic support, gears wear faster, and the clutch may start to chatter or slip. Lab tests like ASTSIMD6278 simulate these conditions by forcing oil through high-speed shearing devices to measure how much viscosity it loses. So when riders complain that their engine feels rougher after a few thousand miles, that's often the result of shear down, not imagination. It's physics, and it's exactly what separates purpose-built motorcycle oil from standard automotive blends. Deposits, the hidden damage you can't see. When most riders think about oil, they imagine lubrication, smooth movement, clean metal, quiet operation. But what really happens over time inside a hot, high-stress motorcycle engine is far messier. Every minute that oil circulates, it's collecting microscopic metal, carbon, and combustion byproducts. And when heat builds up or the oil's detergent system gets overwhelmed, those contaminants start turning into deposits. In air-cooled engines, the problem gets even worse. Temperatures aren't consistent from one cylinder to another. The rear cylinder on a big V-twin, for example, often runs far hotter than the front because it gets less airflow. The result? Burnt oil residue on valve stems, sticky rings, and baked-on varnish in the combustion chamber. Over time, those deposits act like insulation, trapping more heat and accelerating oxidation. Valves can stick, rings can lose mobility, and the engine's efficiency starts to drop. You may not notice it right away, but performance slowly fades. Fuel economy slips, and the engine starts to feel tired. This is where motorcycle-specific oil chemistry matters most. Premium oils use stronger detergents and dispersants, designed to keep carbon and sludge suspended so they can be filtered out instead of baking onto surfaces. They're also formulated to resist oxidation at much higher temperatures, which keeps the oil clear longer and prevents that dark, burnt smell that signals breakdown. So when a manufacturer claims its motorcycle oil reduces deposits, that's not marketing fluff. In engines that live on the edge of heat and pressure, deposit control isn't about keeping things clean. It's about keeping them alive. The chemistry behind protection, additives that make or break it. Every drop of oil is more than just base stock. It's a carefully engineered cocktail of additives. These microscopic chemicals do the heavy lifting, fighting wear, neutralizing acids, and preventing deposits. And in motorcycles, that balance becomes an exact science. One of the most important additives is ZDDP, short for zinc dialkyl dithiophosphate. It's been used for decades as a wear protector. When metal parts get hot, ZDDP reacts to form a thin, sacrificial layer that prevents direct metal-to-metal contact. In other words, it lets itself wear out before your engine does. But there's a catch. While high levels of ZDDP provide strong wear protection, they can also slightly change the oil's friction characteristics, something that matters a lot when your clutch is running in that same oil. Too much can make clutch engagement harsher. Too little can increase wear. Motorcycle oils carefully tune this ratio, so both the engine and clutch stay happy. Other additives, like molybdenum or friction modifiers, are great for fuel efficiency. In cars. In motorcycles, they're usually avoided because they make the oil too slippery for wet clutches. Then there are the antioxidants and dispersants, which slow oxidation and keep debris floating until it reaches the filter. Together, this blend of chemistry determines how long the oil can survive under punishing heat and pressure. So while two oils might share the same viscosity label, their additive chemistry can make them behave completely differently. One lasting thousands of miles longer, the other failing in half the time. Car oil versus motorcycle oil, the reality check. It's a common debate online. Car oil and motorcycle oil come from the same base stock, so why pay more for the motorcycle label? On paper, the viscosity might match, and both may meet modern API service ratings. But what's inside the formula is where the story changes. Car oils are built with fuel economy and emission systems in mind. They use friction modifiers to reduce drag and meet strict mileage targets. They're also blended for engines that use separate fluids for transmissions and clutches, so there's no need to balance wet clutch friction or gearbox shear stability. Motorcycle oils, on the other hand, are designed for engines that spin higher, run hotter, and often share their oil between the clutch and gears. That means they need higher film strength, shear stability, and controlled friction. They're tested under the JASO MA or MA2 standards, certifications you'll never see on a car oil label. Now, could you technically pour a high-quality car oil into a motorcycle and have it run? Yes, in some cases, especially on bikes with dry clutches or separate gearboxes, like many European or vintage models. But in shared sump engines, that shortcut quickly leads to clutch slip, viscosity loss, and faster degradation. So while car and motorcycle oils might look identical in the bottle, they're not built for the same battlefield. One is designed for efficiency and emissions. The other is built to handle abuse, heat, and constant mechanical stress. The difference isn't always visible, but your clutch, gearbox, and bearings will feel it. Testing failures. Finding the breaking point. In oil development, success doesn't start with a perfect formula. It starts with failure. Every motorcycle oil on the shelf today went through hundreds of lab cycles and field tests, many of which ended with burnt pistons, stuck rings, or clutches that simply didn't hold. In professional testing labs, engineers deliberately push oils past their limits. They run long-duration endurance cycles, 200, sometimes 300 hours, under conditions far harsher than real life. High-load segments simulate climbing steep grades or racing at redline. Low-speed heat cycles mimic city traffic in the middle of summer. The goal isn't to make the oil look good, it's to find its breaking point. When the oil finally fails, when deposits form or the clutch starts slipping, that's when the real learning begins. Technicians analyze the residue, check viscosity loss, measure oxidation, and inspect components under microscopes. Every stain, burn mark, and metal trace tells a story about where the chemistry fell short. From there, chemists tweak the formulation, maybe boosting antioxidants, changing detergents, or adjusting ZDDP levels. Then the next version goes back to the dyno for another round. It's an endless loop of testing, failure, and improvement. It might sound tedious, but this process is what separates purpose-built motorcycle oil from generic blends. Each test failure pushes the limits of chemistry further, ensuring the final product doesn't just meet minimum standards. It exceeds them when your engine needs it most. Verdict: worth it or a waste? After all the chemistry, testing, and real-world abuse, the question still stands: is motorcycle oil really worth the extra cost? The answer depends on what kind of engine you're protecting and how you ride it. If your bike uses a shared sump system, meaning the same oil lubricates the engine, gearbox, and clutch, then yes, motorcycle oil is absolutely worth it. It's designed to handle the violent shearing from gears, maintain viscosity under extreme heat, and balance friction perfectly for wet clutches. You're not paying for a fancy label. You're paying for stability, grip, and endurance. But if your motorcycle uses a dry clutch or a separate gearbox, the story changes. In those cases, the oil isn't exposed to clutch friction or gear shearing, and a high-quality car or diesel oil can often perform just as well, sometimes at half the price. The key is to avoid anything marked energy conserving or resource conserving, since those are designed for cars, not bikes. For most riders, though, especially on air-cooled cruisers, high RPM sport bikes, and touring machines, the investment pays off every ride. You get smoother shifts, consistent clutch feel, and longer oil life under punishing heat. In short, motorcycle oil isn't a luxury. It's application-specific protection. And when your oil is doing 3 jobs at once, that extra few dollars at the register can easily save hundreds in repairs down the road. Conclusion: application dictates chemistry. At the end of the day, there's no one-size-fits-all answer in engine oil. What works perfectly in a car might fail miserably in a motorcycle, and vice versa. The reason is simple: application dictates chemistry. Motorcycle engines don't just ask for lubrication. They ask for protection against heat, stability under extreme shear, and friction control precise enough to keep a clutch gripping without sticking. That's a complex balancing act, and it's what motorcycle-specific oils are designed to master. Every lab test, from viscosity stability to JASO friction ratings, points to the same truth. The chemistry inside a motorcycle oil bottle isn't marketing hype. It's engineered for a job that standard automotive oils were never meant to handle. Does that mean you need the most expensive brand on the shelf? Not necessarily. What matters is the certification and the application match. Look for JASO MA or MA2 on the label. Confirm it meets your bike's manual specs and change it on time. That alone will do more for your engine's health than chasing the flashiest product name. The next time you're in the garage, pouring that golden fluid into your engine, remember, that oil is the only thing standing between thousands of moving metal parts and a seized motor. Choose it wisely, treat it seriously, and it'll return the favor every mile you ride. Thanks for watching. If you found this breakdown helpful, consider subscribing for more data-driven comparisons and real-world testing, because in the end, it's not opinion that matters. It's results.